Today's problem is interleaved strings, difficulty medium, accuracy not very high, about 25%. It's a pretty representative accuracy rate given the number of submissions, and the average time's 30 minutes. See, that's kind of high too. Dynamic programming is not easy. If the accuracy is 25%, people are spending 30 minutes on it, well, I don't know. It may be on the harder side of medium, but let's take a look. Given strings S1, S2, and S3, find whether S3 is formed by an interleaving of S1 and S2. It'll probably help to look at some examples of that. Interleaving of two strings, S1 and S2, is a way to mix their characters to form a new string, S3, while maintaining the relative order of characters from S1 and S2. Conditions for interleaving: characters from S1 must appear in the same order in S3 as they are in S1. The same is true for S2, and the length of S3 must be equal to the combined length of S1 and S2. Okay. So here's an example. AAB, AAC. Can we interleave those to make AABC? Yes, we would somehow interleave the first two A's of string 1 and string 2 to get the 4 A's at the beginning. Then we would put in the B from string 1, the C from string 2. So we can do that. This one, A, B, and C, yes. We can take the A from string 1, C from string 2, B from string 3. All good. This one is not going to work. The only way we could even start it is by taking the X from string 2, but then we would have to take the Y from string 1, and that doesn't match string 3. Okay. Constraints. S1 length and S2 length will be between 1 and 300 inclusive. S3 length will be between 1 and 600 inclusive. Okay. Time complexity, O of n times m. Yeah, that's right for a dynamic programming solution. And then auxiliary space, O of m. So that suggests that what they want you to do here is not a bottom up, not a top down memoization solution, but a bottom-up space-optimized solution. Because normally, if you're going to do this in the dynamic programming, you're going to need an array of, a matrix here, space of n times m. All right? But we've seen things like this before where you've got a matrix, but in building up the matrix, you really don't need the whole matrix. You don't need to keep the whole matrix. The only thing that you need to do to compute new values is you need the previous row and you need the current row. So rather than an n by m matrix, you just need two 1D arrays of length, let's see, m. Okay, company tags, quite a few. All right, dynamic programming, good. All right, so let's see what we can do with this. I don't think I can scoot that over anymore. No, I can't. So let me scoot this over a little bit. Okay. We've got S1, S2, S3. Let's get the length of S1. Oh, gosh. Yeah, M and N. Okay, that's fine, yeah. S1 length is M, S2 length is N. Now, we're going to do a sanity check right here at the beginning, because if M plus N does not equal the length of S3, it's not going to work. So we can return false right away. Good. Boolean. DP is Boolean. Dimensions will be M plus 1, N plus 1. In dynamic programming problems with strings and sometimes not with strings, you need to consider a row 0. In that case, this means empty strings. Now we're guaranteed that we're not going to get any empty strings, but to kick off a dynamic programming solution, you need to fill in what you know, even if what you know is never really going to happen. You need to fill it in. So M plus 1, N plus 1. The base case is this. DP at 0, 0, meaning that we have two empty strings. S1 is empty, S2 is empty. Now, we've already checked to make sure that M plus N equals S3. So if S1 and S2 are empty, then S3 is also going to be an empty string. And that means you can interleave two empty strings to form another empty string. So that's true. You know, I should be writing this down somehow. Let's do this example. I'm going to have to, I don't have enough room to make everything visible at one time, but we're going to do AAB, AAC, and then this, AABC. But the only way I'm going to have enough room to do it is down here, and I'm going to pause this while I draw the table. All right, so DP00, base case, right here, true. Now, filling in the first column. The first column, that is, if we just had S1, S2 is empty, and we have S3. What would happen there? Okay, I0, this is starting with 1, 1, 0. So we're going to compare DP at 0, 0, is that true? Yeah, it is true. And S1 character at 0, which is an A, equals S3 character at 0, which is also an A. So that would work as far as it goes. The second letter would be the same. AA in string 1 would match AA in string 3, so that's true. But the third one, AAB, the B is not going to match string 3. So that is false. Okay, next. Let's see, fill in the first row. So that is imagining that we could have an S2 with an empty S1. All right, so DP at 0, 1 is right here. DP 0, 0, 0 is true, yes. And first character of or char at index 0 of S2 is 0. Does that match char 0? I'm sorry. Char at index 0 of S3, and it does. So that would be true. Same thing would be true for the second one. We would match the second A as well. The C is not going to match, right? So that's everything that we know. All right, now we can fill in the rest of the table. And let me just do it like this. I'll write these down here as we go. I starts out as 1, J starts out as 1. K, which is the index for string 3, will be I plus J, because we're interleaving string 1 and string 2. So however many letters we choose from string 1 and 2, the combined, the sum of those letters will be our index in string 3. So that would be 2. All right, so let's start with trying to find out DP. We're going to add another letter, DP, IJ, 1, 1. Don't do that. Okay, so we'll check and see if DP I minus 1, DP at 0, 1. DP at 0, 1. Yeah, that's true. And S1 char at 0, which is an A, equals S3 char at 0, which is also an A. So that would be true. Whoa, I'm sorry. S3, no. S3, K minus 1. K is 2. 2 minus 1 is this second A. So yeah, that's still true. So what that means is if we took one letter from string A and one letter from string B, that we could make, they're both A's, that we could make this AA at the beginning of string 3. All right. Now J goes to 2. Ki plus J goes to 3. Right, next, 1, 2 equals DP. DP 0, 2 is true, and S1 char at 0, which is an A, is equal to S3 char at K minus 1, which is 2. That is also an A. So that would be true. What does that mean? That means one letter from string 1 and 2 letters from string 2. If we had those, we could make the first 3 letters of string 3. So yeah, we're good. All right, through the loop again here. This goes 2, 3. This goes 2, 4. This is not going to work. So what we're going to have now is 3 letters from string 2 and 1 letter from string 1, which is A, C. Can we make the first 4 letters of string 3? And the answer is no. It's false. DPI at J minus 1 is in fact true, but S2 at 2, which is a C, that doesn't match. It doesn't match in string 3. All right. Let's see. Let's get rid of some of these and start the next round of the loop. Okay. So this will go to 2. This will go to 1. This will start out as 3. All right. So what we've got is 2 letters from string 1 and 1 letter from string 2. Other than go through all the computations, 2 letters from string 1 and 1 letter from string 2 will make the first 3 letters of string 3. So that is true. Also, 2 letters, if we went to the next one, 2 and 2, and then this would be 4. 2 letters from string 1 and 2 letters from string 2 would make the first 4 letters of string 3. So that's true. Okay. Next, this goes to 3. 2 letters from string 1 and 3 letters from string 3 will not make the first 5 letters of string 3. The C doesn't match the B, so that is false. All right. Let's erase this. Last time through the loop. I is now 3, J will start at 1, and K will start at 4. All right. So 3 letters. 3 letters from string 1 and 1 letter from string 2. That isn't going to work, but I mean, let's just look at it anyway. What do we have? I minus 1, 2. DP at 2, 1, 2, 1. That is true. S1, char at 2 is a B. Does that match string 3 at character 3? It doesn't. All right, how about this one? DP at 3, 0. No, that's false. Okay, that isn't going to work. It's false. What if we had 3 letters from string 1 and 2 letters from string 2? Now that'll work. That will make the first 5 letters of string 3. Okay? That is true. We can take A, B, A, we can interleave those, and we can make, and I mean, if you look at it in the computations here, DP, whoa. This has got to go to, I'm sorry, next time, that's got to go to 2. This is going to have to go to 5. All right. DP, I minus 1. DP at 2, 2. It is true. S1, char at 2 is a B. Does that match string 3 at index 4? And in fact, it does. So that's why that is true. And the last time through here, this is going to go to 3. This is going to go to 6. You can already see that it's going to work, but if you want to look at the computation as well, DP at 2, 3. 2, 3. That's false. How about DP at 3, 2? DP at 3, 2 is true. All right, good. So how about string 2, char at 2, which is C. Does that match S3 at index 5? 0, 1, 2, 3, 4, 5. Yes, it does. And so that is gonna work, and we'll return DPM MN, which is this. Okay. Let me erase this because we got to do one more thing. And that is because we were asked to do this with a complexity of O of M. That means we really need to convert this to, auxiliary space. Yeah, our auxiliary space here is O of M times N, but we can fix that. So let's try this. M1 is S length, M2, N. Okay, so this is all fine up to here. Boolean, this has to change. So Boolean, we need a one-dimensional Boolean array, which we're going to call previous, and that is new Boolean at N plus 1. Okay. It's just one row. All right, we will have a Boolean array called current. Oh, shoot. You know what? Before I start goofing around with that, that is the way it was before, right? No, it was Boolean BP. All right, let's try and run this. Let me make sure I didn't screw it up. I did screw it up. Okay, good. Let's see. Oh yeah, it needs another. Needs 2D array there. Okay, let's try this. Case 1, that worked. All right, let's try submitting it. Okay, that works. Good. Now we can start changing it. All right, so Boolean. We need two one-dimensional arrays of size n plus 1. Two rows. The first one, we'll call it prev. The second one, we'll call it current. We don't have this two-dimensional array anymore. We just have rows. So we're going to call previous at 0 is true. First row. All right, so this, there is no first column anymore, but we may need that later. Okay, so fill the first row. So int j plus 1, j is less than or equal to n, dp0 is going to become prev. So prev j equals prev j minus 1 equals, and the character checks are still fine. I need to move that over. All right. Fill the rest of the DP table for int I is less than m. All right, now we need something here. Because we didn't fill the first column. So that means that the row, every row after the first row, the first cell is going to be empty. And we need to fill it here. So for int I minus, okay, we already have that. So what this is going to be is dpi is going to be current. dpi is going to be current. dpi minus 1 is going to be previous. All right, so current, and we don't need that. For the current row, cell 0 will be previous at 0 and do the characters match. All right, now for int j, okay, that's fine. Now dpi, again, is going to be current. Is there anywhere else that we need to change that? Yes. So right here, it's current. dpi minus 1 is going to be prev. Current equals prev and, okay, and then we do the character match. Current j minus 1 equals, and then we do that. All right. Again, you may have noticed as we went through the building up of that array that in order to get new values, we only needed the current row and the previous row. Okay, we didn't need the whole matrix. So every time through here, then we are going to set previous to current. And we're going to clone it. We don't want them like just pointing to each other. All right, so we go through, and then every time we move current to previous and recompute current. Return. Now, we don't have a two-dimensional array anymore. I don't think it matters whether we return previous or current here, but let's return previous and see what happens. I need to do a compile on this to make sure. Okay, that worked. All right, so here we go. Okay, good. So the reason for doing that is to get an O of M auxiliary space. You may be asked to do that in an interview. Probably, I don't know if I would try to do it just, you know, on the first try. I think I would just go ahead and build up a bottom-up dynamic programming table and then convert it to 1D arrays. I think that's the way I would do it. But yeah, that's it. So it's kind of, yeah, it's not what am I trying to say? That it's on the harder end of medium, which again is I think what you would expect from this kind of accuracy and this kind of time, which is, it's actually pretty good for um, for most programmers, but the kind of programmers who hang out on Geeks for Geeks doing programming challenges, 30 minutes is actually a pretty long time. So that's it. I hope you will like the video and subscribe to the channel. If you subscribe to the channel, you can subscribe to notifications. And that's it. We'll see you next time.